afternoon, everybody. Happy to see you here. My name is Göbel. I'm going to be presenting deploying and managing LabVIEW Toolkits for the next hour. Maybe a short introduction on myself. Göbel, my name. I'm a senior support engineer from Munich, Germany. I came over here most specifically for this presentation, actually. Elijah Carey, maybe some of you know him, invited me for that topic. I started at NI in 2014, and I'm working as a support in the support department since. I'm certified LabVIEW architect. I actually just recently got my certified LabVIEW embedded developer through. I'm quite happy about that. So now I'm all through the certifications that we offer. And yeah, my hobbies are AI, music, coding. I kept it general. I have a lot of private interests, I would say. We can chat about those later. Before we get started with the topic, Elijah asked me to shamelessly commercialize on this event, or these events. Who in the room knows GDevCon? Oh, quite some. For the rest, maybe. So GDevCon is a community organized event for LabVIEW programmers. There's all kinds of, usually technically deep diving sessions about LabVIEW. Very interesting, very technical. And also this track here right now is called As Seen on GDevCon. So actually the presentation that we're talking about today I've been presenting that on GDevCon together with my colleague Chris Roebuck. Maybe somebody knows him, a very experienced engineer also from NI. And so sadly Chris didn't join for the session today. Well, so it used to be more of a lighthearted conversational session that we did on GDevCon. But since he's not presenting, I felt like I would just put more content into it. So we're actually going to be kind of deep diving into package deployment for LabVIEW packages, how to distribute your own toolkits, what possibilities you have, what pros and cons there are, and what to use for what. If there's any questions, feel free to just raise your hands. I'm always happy to answer them right away. And we, of course, will have time for questions in the end as well. Yeah, and so if you're interested, check out those dates. There's a North American one in Chicago coming up in July. So I can highly recommend if you're interested in LabVIEW. All right, so let's get started. We have a scenario that I'm going to use as an example throughout the whole application. I've been using that power supply, which is a single DC power supply, very simple in functionality, one channel, and I wrote a driver for it. So I've been writing a simple API. We got init, set mode, set voltage limit, few VIs to initialize it, read and write VIs, close VI, and yeah, so that way I can work with it. And my challenge now is I want to pass this code on to a colleague, like a colleague who's working, or we will talk about other scenarios later, but firstly, talking about a colleague that wants to use that power supply. The power supply, as I said, consists of an API, so a set of sub-VIs that I want to pass on. It also has some examples up here. There's one for sourcing current, one for sourcing voltage. And just to make it a bit more complicated, we have a dependency down here. So that's another library I wrote, my useful math library. There's some math functions in there that I like to use throughout my projects. And that's a dependency of my project at the moment. Now, the big question is, how do I hand this over? How do I bring this to my colleague without missing anything, without having him to do a lot of things or follow a lot of instructions? So, first thing that may come to many people's minds, and since I'm working in the support department, I actually seen this quite a lot, is a zip file. We get zip files sent by customers very often. It's of course the easiest way, just right click. You may use a tool like 7-zip, create a zip file, and hand it to your colleague. The big problem, or maybe first with the pros, it's very easy. There's no additional software to open. Windows can just open a zip file. But of course the cons, code can be edited. Freestyle distribution, I have to maybe send it to him via email, give him a USB stick or whatever. And the worst part, no dependencies. So you may find yourself opening the toolkit and it's not executable, error is broken because there's my useful math library missing. So that brings us to the first, let's say, real approach, how to pack that, which is a source distribution. So we can create a source distribution in LabVIEW. It's a build specification that we can create in our project. And then we can select things that should always be included. In this case, it's that power supply driver LVLib. So we already have a library for that. We could also just put some sub-VIs in there. And LabVIEW will then parse through the sub-VIs, find out all the dependencies that are needed, and put them in a single folder on the disk. So we have my useful math library here, which is our dependency. And we have our driver library down here. So now I can pack this into a zip file. I can copy it any other way, put it on a network drive. My colleague can pull this file and it will have the dependencies included. It's still very easy to use. There's no additional software to open this. It's just a folder, or I might use zip file maybe. It has all the dependencies, but still the code can be edited, which might be an issue, might not, depends on the use case. And there's freestyle distribution, so I still have to see how to get it to my colleague. As I said, network drive, USB stick, email. And freestyle destinations, so when I'm giving it to my colleague, he maybe doesn't know where to put it. He might put it in his project folder and then drag it in manually, but he might put it into some central place on his computer. So I have no control over that, and it's hard for me to make suggestions where he should copy these files. Another way I might be handing over this code is a packed library. Packed libraries, I'm not sure when they were introduced, but quite a few years ago, they're gotten quite common. It's again a build specification I can create in my project, and then I have to select a top-level library. So in this case, I cannot use single VIs. I have to use an LVlib, select that LVlib, and then I will get a packed project library, an LVlib-p file, and that's a single file containing all the contents of my library, including the dependencies. So also my useful math library will be in there, even though it's not visible in the screen, it will be part of that LVlib-p file. That's very handy. I can have a single file, I can very easily copy that around. It cannot be modified because it's compiled, it's finalized. There's some other benefits also that go with it. I can remove the block diagram of my VIs. So if I want to protect my IP, for a colleague, maybe not the use case, but if I'm giving this to a customer, I want a customer to use my driver, I might want to hide the block diagrams. And of course, I can use a password protection for my VIs. That's another feature, but as some of you may know, the password protection for LabVIEW can be cracked in multiple ways. So if you remove the block diagram, you're really safe not to give away your IP. It's really just the sub-VIs that they can use. Yeah, so PPLs, it's a single file, that's very useful. A big benefit of that is the performance. So they are compiled. So especially if I'm working with large projects, if I got large libraries that I'm sharing, this is very useful because my project loading times will be much shorter. So basically when I'm opening the project, it's just opening some pre-compiled libraries and it doesn't have to go through all my source code every time. So that's actually one reason why many people are using packed libraries, just to reduce the loading times on large projects. Yeah, of course we can remove the block diagrams, which I just mentioned, and all the LabVIEW dependencies are included. So other libraries that I wrote sub-VIs to them, and so on. Downsides to that, complex build process. So when we come to object orientation, maybe a quick hand sign, who of you has done a hardware abstraction layer in LabVIEW using LabVIEW OOP? Okay, it's a few hands. So when we're doing things like that, like hardware abstraction, there's not necessarily just hardware abstraction, any kind of abstraction, any kind of plug-in architectures also. We might want to use PPLs for that. So we may build our child classes into packed libraries and distribute them that way. But that comes with some issues when we come to PPLs. And yeah, it's making the build process and everything a bit more complex. So once you stumble over that, maybe send me an email and I can send you some references to that. There's a lot of things to keep in mind. The other thing is complex build process recursive. So if you have packed libraries that depend on packed libraries that depend on packed libraries, and you do a change in the lowest level packed library that you have, you will have to recompile each of the packed libraries all the way through. There's also a tool in the community, which I wanted to put on the slide, that will automate that. So that will recursively recompile your packed libraries in such a case, but still it's a tedious process, it's time consuming. So yeah, it's also something we might want to avoid. And one big point also to keep in mind is it's version sensitive. So if I'm compiling a packed library for LabVIEW 2022, it's always being fixed to that version because it's compiled code. We cannot recompile a packed library. All right. We stick with the LabVIEW onboard tools. Who of you has been using a LabVIEW installer? Classic one. Oh, there's quite some hands. Yeah. So, I mean, basically, if you ran through our LabVIEW Core 1 training, probably you've been using it at least once there. That's what we recommend to distribute your executables. So maybe you might be building an executable, then you build an installer, it will put the executable to a specific place. We can also use LabVIEW installers to distribute source code. We can do that by adding paths to our destinations. So just for those that maybe haven't used it, it's also, again, a build specification in the project, LabVIEW installer. Then we can add in this case, static path to the C program files LabVIEW 2025 VI lib and put a subfolder in there, put our toolkit VIs there. So let's go on the destinations page. We can move all our VIs into that path that we have included. We do have some other, going back real quick. We do have some other destinations that we can place stuff to. We have a 2025 examples directory here, for example, that we can place code in, the help directory to place our custom help files for our toolkit in, and so on. So there's already quite some destinations that we can use, but it's not a ton. We're gonna get to tools that offer more. And there is, and to mention, when we use a dialog, when we use an installer, we can customize the dialog. And that's actually at the moment still a big benefit of using a LabVIEW installer. So you can create a custom license agreement and README file that will show up during the installation process. You can create a custom welcome graphic and banner graphic. So that's basically the graphic shown on the main launch screen here and on the banner on top of each page. So this can all be customized to fit your company style, have your company logo or your toolkit's logo. So when you try to brand your product, a LabVIEW installer is a very nice solution for that because you can really ship it to a customer and it looks like a real product that you are providing that way. If you want the toolkit to show up in your palette, you can do that with a LabVIEW installer. So as I mentioned, there's some destinations here, and there is also the LabVIEW 2025 palettes folder. So you can go into your LabVIEW project, go to Advanced, Edit Palette Set, and that will let you create a new sub-palette for LabVIEW. And in that sub-palette, you can insert all your VIs, design it, make folders, and so on, and save it as an MNU file. And then you can configure your installer to place that MNU file in the palettes directory. So that way, when a customer is installing your toolkit, they will automatically have it popping up in your palette. Caveats when it comes to LabVIEW installers definitely is the version dependency. So as you can already see with the destinations, it's all LabVIEW 2025. And even if I'm adding my own paths there, it will also say LabVIEW 2025 VI lib. I cannot be version independent, make an installer that detects the LabVIEW version and so on. So if I want to distribute code that way, I will have to create an installer for every single version of LabVIEW that I support at least. And then maybe provide different ones to my customer, or maybe I will have a download page where they can select the right ones. But yeah, it's more of a complicated process. I have to do a lot of manual effort to work with different LabVIEW versions. And another thing that you might stumble over when using this is developing examples. So as you can see on the left side, in my development directory, the examples are placed in the examples folder. Next to that, there is a source folder that is containing my API VIs. So if I'm just moving my examples to the LabVIEW 2025 examples folder and my API VIs to the VI lib folder that I have created, the relative path between them two will differ. Like it won't be just one subfolder down, one subfolder up. So the examples will not be executable anymore. And that's, I would say, quite annoying issue that leads you to actually installing your installer first, then building your examples based on the VI lib location, and then building it again using the examples. which is quite an intense process. You might use other ways to relink that in some way, but that's definitely a challenge when using installers. Still, if you want to brand your product, it might be worth going this effort or doing this effort just to have the nice appearance of the installer. So, pros and cons. There's no additional software needed. You can do this all with LabVIEW environment, so that comes with LabVIEW Professional. You can have a custom appearance, which is the big pro, I would say, for the LabVIEW installer. It's LabVIEW native, and you can include additional installers. I didn't show that separately on the slide, but you can have the installer also install the correct DACMX version and NI scope and whatever your application needs. You can also have third-party installers included into that. Negatives, there is no relinking of examples. That's, I would say, one of the biggest issues that I've stumbled over, because that's really annoying to solve. It's version sensitive, so it's always just for one LabVIEW version. There's no automatic dependencies, maybe also something worth mentioning at that point. So the LabVIEW installer is not automatically pulling my math library into the installer if I'm building it, but I would, for example, have to create a source distribution first. So I create a source distribution that has all the dependencies, and then I'm publishing it using an installer. And there's static paths. So I really have to put in the paths exactly where I want to install it. If the user has maybe installed LabVIEW to a different directory, for example, I may have issues using my installer correctly for toolkits. All right. So far about that, we get to a nice solution actually for all these issues. No worries. One more thing I want to mention at this point. The NI package. Who of you has used the NI package manager? And it should be quite some hands. If you've been using LabVIEW, you probably installed it using our package manager. You can use the NI package manager to distribute your toolkits, though it's not recommended. So we officially discourage to do that. I just want to mention that it's possible. So the one benefit that you would get from doing this is that your toolkit will show up in the NI package manager for the customer. So for some toolkits, that might be something you want. But it's a minor benefit, I would say. And there's some caveats similar to the installer that come with the NI package. So again, you don't have that many destinations to go to. You would have to add your own static paths to the package. And also just to mention, the package can also be created as a build specification in LabVIEW. And but it's the same thing. You have static paths. You cannot dynamically choose a LabVIEW version. And you can add dependencies to a package, which brings a little benefit over the installer. So the LabVIEW installer, when you're including additional installers, you're statically including them. So basically the installer is going to get bigger and bigger, including the DACMX installer, scope, and so on. With NI packages, you can refer to different other packages in a specific version. So if the package might already be installed on the target system, it does not have to be included in my package. So my package really only contains my code. It's quite slim. I don't have to roll out that much, don't use that much memory. And later on, the package manager will, it will solve all those, resolve all those dependencies and check which are already installed in which version, maybe upgrade some, pull them from the internet. So it's a bit more flexible way of handling packages or handling additional installers. And another thing I can do is I can create a package installer from it. So basically, when I'm just building a package, I have to have the NI package manager installed. So I have to open it in the NI package manager. So I have to require my customer, my colleague, and so on to already have that tool on their machine. If I want to not have them to pre-install something, I can create a package installer from my package, which makes it a single executable that will install the NI package manager and then install the package using the NI package manager, which again is a more handy user experience. But the important thing to keep in mind here is that I cannot customize the installer appearance. So I don't have this benefit of making it look like my product. Just to teaser that here a little bit, I know that R&D is working on that actually, because the LabVIEW installer, it's, as I said, it's a kind of a static way. It's been around for a long time. It's a quite old technology. And still, it's very important for many of our partners, many people that are distributing toolkits as their products. And so we try to get this experience into the NI package manager, but it's not implemented at the moment. And I, at the moment, don't know how it's going to look, because of course the whole NI part of it would have to be hidden. There shouldn't be any NI logo. It should be all looking like customer code. But yeah, I know that we're working on that. There might be some updates in the future on this. Yeah, but you can create a package installer, and what you can also do, you can add your package automatically to a feed. A feed is basically a folder on a network drive on the web that the NI package manager can link to. So I can tell my colleague to add a specific feed in their NI package manager, and then I can always, when I have a new version of my package, put it into that feed, and the colleague will automatically get a notification that there's an update for that package. So that's a quite useful mechanism I can use to automatically roll out the code. But as I said, all in all, we do recommend, of course, the NI package manager for application distribution. So if you're building an EXE, if you're building some tool that you want to hand over, that's where the NI package manager should be used for. If you're building toolkits and you really want to distribute source code or reusable code, that's not what you should be using. Positives, LabVIEW native, links to additional installers. So that's, of course, again, maybe if you have a ton of additional installers your toolkit depends on, it also might be a solution to shrink down the installer size. And you can publish it through a feed. But again, there's no relinking of examples. So you have the same issue as with the LabVIEW installer. The examples will use their relative path, which is an issue. You don't have too many destinations to put it to, or non-automatic ones. You always have to put static paths in there. It's version sensitive for the LabVIEW version. And no, yeah, it doesn't pull in the automatic dependencies. Yes?
Is there a way to do this where it's not visible to the entire world? Like if you just want your executable is full in your company?
Yes, so the question was if we can publish it privately, basically, and not publish it globally. Absolutely. I'm not even sure if you can just publish it through our feeds or repositories or however you would call it. Basically, what you can do is do it with your own feed. So you might have a network drive, and in the NI package manager, in the top right, there's a configuration menu to add your feeds. And then you can add like a normal web address from inside your company, and that's where you're going to be pulling the packages from. So in that case, you're never making it public, basically. And we're getting to the whole publishing part also towards the end of the presentation. There will also be a separate section on how to publish it with the different tools that we're looking at. Any other questions at the moment? Yes?
I can speak into it, I suppose. With the package installer, creating a package installer thing, if you already had NI package manager installed, would it kind of gracefully like skip, or like it wouldn't downgrade you or something like that?
No, absolutely. It would gracefully just skip the installation, realize you already have the package installer on your the package manager on your system, and it would just install the package in that case. Yeah. All right. Oh, yeah.
Actually, I have one more. At the beginning, we were talking about the PPL pack library recursive, and you said there was a tool. Mm-hmm. Were you referring to MGI Solution Explorer, or was it something else?
Again?
You were talking about the recursive issue, and you said there's a tool to like recompile the extra layers.
Yeah, I didn't have the name in mind. What did you say?
MGI Solution Explorer?
Solution Explorer, yeah, exactly. Okay. That should be it. The MGI Solution Explorer is the tool that can build your PPLs recursively from the ground up, starting with the lowest one. It's very useful. Yeah. We're going to get back to MGI also later with other toolings. All right. So, getting first of all to the, I would say, most interesting part, and I would say the solution that solves a lot of the problems that I've been mentioning before, the VI package. Who of you has been using the VI package manager? Nice. Who of you has been publishing their own packets for the VI package manager. Okay, it's just a few. So the VI package manager, most have already used them because we ship it with LabVIEW now. Just important to keep in mind, it's a JKI product from Jim Gring, written by him. And it's been around for quite a long time. That's what you use to get toolkits for LabVIEW, OpenG and whatnot. Everything is available there. And the VI package manager looks like this. You probably have seen it. You can select a bunch of tools there. It has a global repository of packages. And of course, you can get VIP files, which are packages for the VI package manager that you can install, and you can share them separately. If you want to build your own package, you can easily do that with the VI package manager. You don't need any special license for that or so. You can just go to Tools, Build Package, and then you will get a VIPB, so a VI package build specification, I guess it stands for. That allows you to specify a source directory. It's containing all the code that will be included in the package. And it will then have, again, different destinations that it can link to. So as we saw before in the installer or the NI package manager, you can install, for example, to your examples folder. You can install, that's what I'm saying about the others don't have too many destinations because VI package manager got a plenty. So you can install custom probes, you can install custom errors, help files, template VIs, the tools menu, and so on. So you can have your quick drop plugins delivered with your package. So this is all already resolved by the VI package manager. It knows all these paths and it's also getting them dynamically. So even if I change the install destination of LabVIEW, the VI package manager will still get them to the right folder and I don't have to use a static path to somewhere. Yeah, so here's just to show as an example, if I use the examples destination for my examples, I also will get a small button when installing the package, and that will lead me to LabVIEW 25 examples NI that power supply, and in there will be my example files. And I think I'm mentioning it separately, but those examples will also be relinked by the VI package manager. So the issue we had before where the relative path from my example to my library is not correct anymore, that is solved by the VI package manager, which is a really nice feature, I must say, because then I can just develop my examples next to my source code. And when I publish the package, it will still work afterwards, no matter where it's getting installed to. Another very handy feature is I can create my own palettes for the toolkit, and I can directly do that inside the VI package manager. We saw before I could go to Tools, Advanced, create a palette set, have the installer place it in the right folder. We can automatically do that inside the package builder, the VI package builder, create our palette, and it will already automatically place it in the right destination. Another feature, we can password protect our VIs. As I said before, if we don't want anybody to tamper with the code or to see our IP, this is of course a way to do it. Little note, if I really want to be safe, as I said, the VI password protection is not bulletproof, I would say. So I might use a PPL inside a VI package. The PPL allows me to remove the block diagram, and I can still deliver it as a VI package and use a palette and all these features. That way I can easily protect my IP, but I have to be aware that this makes the package version specific because the PPL cannot be recompiled. So as soon as I'm doing that, I'm getting stuck on this exact version of my PPL. So then it's only for LabVIEW 2025, for example. Another great feature, that should be right on the bottom here, is enable renaming. So I can add a prefix to all my files inside a VI package, which is quite useful if you're opening your toolkits VI, like your source code VI, and you're changing something and maybe you're working on the examples, but you also have the package installed. You may get into situations where you're getting conflicts because you have like a VI from the VI lib somehow accidentally pulled into your code, and you have the VIs from the source code folder, and they will conflict because they have the same name. That can be worked around by adding a prefix to the VIs when they're getting installed, and you can always differ. And it's also easier for you to see which version you're currently having open. Am I using the example from my source code folder? That one will reference to the original VI names. or am I using the example from the examples folder? That one will be referencing to the prefix names. So again, all small helpers that work around all these issues that you may have with the other deployment mechanisms. So there's really a lot of thinking going into that. Another thing is the dependencies. So with the VI package manager, similar to the NI package manager, I can link to other package dependencies. And of course, in this case, it's VI packages. So I can say, for example, my toolkit needs the OpenG array library. Or since we've been talking before about the my useful math library, I could have been building that one into a package before and then link my second package to the first one and so on. There's also VIPC files, VI package configurations that I can create that will include exactly this information. So actually when I'm building a package this way, it will automatically create a VIPC file containing all these packages and their versions. So I can also give that VIPC file to a colleague, like if they're not using my package to install, just to install all the necessary dependencies. And there is we get to that in 2 slides. There's also another technology from JKI that they invented, because right now the VI package builder or the VI packages, they do not install NI packages. So I cannot have DECMX rolled out in a specific version with my toolkit, for example. But we get to that in a second. There's also a solution for that. Another tip that came with LabVIEW 2026. Who of you upgraded to LabVIEW 26 already? Well, that's just a few hands. So when you do, you will find yourself getting additional folders in your project directory. So there is this .that powersupply.userstate folder. This one is containing a single file containing user-specific or machine-specific debug information. So one thing that came with LabVIEW 2026 Q1 was persistent probes. So when you're setting a probe in a VI and you're closing the VI, you're closing the project, usually the probe would have been gone, which can be annoying when you're doing like heavier debugging. And now the probe will be stored in this folder. So it's like just a few lines in a text file. And when you open the project again, it will show those probes again. So this is a nice feature while developing, but of course I don't want to roll that out when I'm deploying my package. So highly recommended to exclude this folder. Also mentioning at that point, if you ever run into that, if you're using Git, you should also put this folder to the Git ignore so that you're not checking it into your repository. It's just meant to be on your machine for your state of work, basically, or your state of debugging that you're in. Okay, very nice feature of the VI package manager. It doesn't only work for one version. So if I'm building a VI package, I can select which version I want to build it for. And if the source, or basically if I'm having a newer version of LabVIEW, so if I'm building the VI package for 2020 and I'm using 2026, the VI package manager will automatically mass compile all the code that's in there and put it in my 2026 directories. So I can have one package to use for all versions. If you're building your own packages, there's a very neat feature because earlier, a few years ago, you would have had to use the save for previous version. So let's say you're developing in LabVIEW 2026, you save your project for 2020, then build a package out of it, and then distribute it so everybody can use it with 2020 plus. You can now get around that quite easily using the editor version independence. So if you go into your project, right-click Properties, this started with LabVIEW 2022, you can select a safe version for your whole project. And you can put this one to LabVIEW 2020. That way you're still working in 26. You don't have to have like a copy by save for previous version, but you would just say, hey, everything should be saved compatible for 2020. And then you can build your VI package right from that. So it's a big recommendation to using that feature when building. And in general, it's a big recommendation to use the lowest possible version for your toolkit when you're trying to distribute it. So in my case, I usually go to 2020. Anything older may have some issues anyway. And yeah, that's the way to go now for that. All right, so VI package manager, pros and cons. You can easily add palettes, which is a super handy feature, which is a bit tedious when you're doing it manually. You have very good dependency management, just as with the NI package manager, so packages can rely on each other. You have installation management, so the VI package manager will install the files for you, detect the right locations for it, detect where LabVIEW is installed, and so on. And you can have version management, so you can version your toolkit, customers can install, or colleagues can install specific versions of your toolkit, upgrade them, downgrade them, and so on. It's very helpful. Negatives. The code can still be edited, except we're using a PPL. But as I said, if we're using a PPL, we're giving away a lot of the benefits because we have to make it version specific. And of course, it's third-party software, though we are closely collaborating with JKI, of course, on this product. And an important point is I can only have one version of a package installed at the same time. So let's say I'm having 3 projects I'm working on, and each is using that power supply driver, but in different versions for some reason. I would constantly have to upgrade, downgrade those packages if I'm working on a different project. That can be automated using the the JKI Dragon. Who of you has used the JKI Dragon so far? Few? Yeah, so JKI Dragon is a tool that will scan your whole project. So you can basically open it and then open your project through the Dragon. And it will know which LabVIEW version to open it in, because it will read from the last version you saved it in, basically. Open it in the correct LabVIEW version. And it will scan your whole project for dependencies as well. VI packages, just as NI packages. So then the Dragon can install everything you need when it comes to the dependencies when you're opening a project. So if you're having 3 different projects that you're working on, they require different versions, Dragon can do this upgrade, downgrade mechanism automatically for you. Still, it is kind of tedious a little bit because it has to upgrade, downgrade. That comes just with the fact that VI packages are always installed into the VI lib. So there's just this one folder where the VIs reside in. And yeah.
Does it get cached locally, or does it have to have a network connection to download packages every time?
That's a good question. If they get, I'm not sure if JKI Package Manager is caching them in between. I'm thinking because it should do that, because it should download the VIP file to some directory, and I think it's already, if it's already there, you don't have to download it every time. But I'm not 100% sure. I can check afterwards. Yes.
Yeah, so there's actually a cache folder that you can get all the versions of each VIP, which already is part of Dragon as well as the VIPM. So they're already cached locally. If it's already there, then you're fine. The other option is that in VI Package Builder, you can now install to the VI add-ons folder, which is under program data /ni/VI add-ons, and there it's version unspecific. So it doesn't have to go to VI Live for each version of LabVIEW. The new direction they want to go to is put it in VI add-ons so it's not tied to a specific version of LabVIEW. So that might help.
That's a very interesting point you're talking about it. That I was thinking about putting LabVIEW add-ons into the presentation, but I didn't see that the package builder can automatically do that.
You have to create your own destination.
Yeah, okay, but then So maybe for everybody, there's a LabVIEW add-ons folder now that is version independent, so you can have toolkits installed for LabVIEW 2025, 6, and so on for all versions in a single folder that is C program files /ni/LV add-ons. So it's independent of the LabVIEW instance that you're using. And because that's what I had in mind. What you can do, maybe to go back a few slides for that. You can create a custom destination down here. You can add a plus and just add a normal path to it. And there you can add the LV add-ons folder. And then you can put your toolkit into the LV add-ons folder, and in there will be a subfolder for your toolkit. And in that subfolder, you can have another subfolder for VI lib, for examples, for resources, and so on, for all the folders that would be in the LabVIEW directory. And then all the LabVIEW versions will share that instance. And that way you can use the VI package manager to distributed for multiple LabVIEW versions. But it comes with a caveat, if you don't correct me, that I cannot use the palettes in that case, because the palette file will, when we go back to this feature, so if I'm defining the palette in the VI package builder, it will always go into the directory of the selected
It
version.
will relink, it will search in the VI, the add-ons first to recreate and relink the palette.
Oh,
It happens automatically now.
okay, all right. Then
2026 and up, we'll relink for you.
Okay, nice. Then
Yeah.
I have to check that again. Okay, then
Yep.
that's all.
Small
Thanks.
little thing.
Yeah, that's the little.
I think Greg Richardson featured it at the GDevCon, so there's a video on it if you want to learn more.
Oh, okay, cool.
Yep.
Yeah. Also, Greg also mentioned that with the LabVIEW add-ons folder, it's very nice already that you can have your versions installed for all kind of LabVIEW versions. It also features installing multiple versions of a toolkit into the LV add-ons. So in the LV add-ons, you always have a subfolder, version 1, 2, 3 of your toolkit. And it's an idea. I'm not saying it's going to be implemented soon, but I really like the idea to have your project file decide which version of a toolkit it wants to be using. And then it can link to that specific toolkit version in the LV add-ons, which is, I would say, the ideal solution for having these multiple projects, multiple toolkit versions. But coming from the pros and cons, only one version at a time here due to the global installation, I want to mention one more package manager that has gotten a little out of sight for many people, which is the G package manager. Who of you has used the G package manager? Okay. 2 people. Yeah, it's quite exotic these days, I would say, but I reached out to MGI, More Good Ideas, about this, and they said that it's definitely alive, that they're also working on it. You can see on the GitLab that there has been some new pushes this year, so there's definitely activity on it, and there should be some more packages coming up. I'm just briefly mentioning it here. The big benefit that goes around this multiple version issue for G Package Manager is it's installing the packages into your project directory. So it's not installing to VI lib, but it's just making a subfolder next to your main VI with GPM packages and put all the code in there, which is quite handy for using continuous integration, for example. When you have a build server and you have different projects that you want to build, having the dependencies in your project directory makes everything easier because you always have the version that you need in there. And it's not like one global one that you need to upgrade, downgrade, and so on. So that can be very handy. Just to quickly show the UI for creating a package with the G Package Manager, most of the functionality of the G Package Manager is command line based. So it's also not as easy to use, but of course it's very handy when it comes to continuous integration because you can very easily automate it. But you can already see there's not so many features. Of course, you cannot have palettes for the toolkits in G Package Manager because it's not part of the VI lib, so it's part of your specific project, so the palette couldn't directly point to it. And so it's more of a package manager for automated tasks and less for just installing the package, writing code with it, and so on. But big pros: installs your VIs into your project directory. It has a smart dependency resolution, so when you have multiple packages that depend on the same dependencies, it will make sure not to duplicate each of those dependencies. And it's free and open source and published by MGI. But of course, no palettes, limited UI, but therefore it can be automated through command line. Right, questions up to that point? Okay. Then we will get into publishing. So I was just talking about how to build the packages. I was already mentioning with the NI package manager, we can have a feed that's automatically publishing our package inside our company from our network drive or something like that. And I just wanted to go over different options for all the other package managers that you have. I mean, starting simple again, you can send your package via email, any of them. You can build a zip file, source distribution, and so on. Super easy, no additional software. But of course, no updates, notifications, no version hierarchy, no central storage or central repository for your packages. Can improve it a little bit by using a network drive. Then you will have a central station, of course, where your colleague can pull down your files. But yeah, it's still not nicely managed. You may have then multiple zip files with version numbers or something like that, but it's still not quite handy to use that. The one that I like to recommend when you're using VI Package Manager is the VIPM community publishing. So most of the toolkits or all the toolkits basically that you see in VI Package Manager are published as an open source license in the community publishing. Yeah, it's very easy to do. It's publicly accessible, so everybody can download your toolkit. And you have version management, so VIPM keeps all the versions of your toolkit. But of course, that's the big negative point about it. Your toolkit must be open source. So it depends, of course, of what you're building if you want to do that. And it's running or it's hosted on third-party servers. So it's hosted on vipm.io. But still, I highly encourage everybody who's developing some nice toolkit that can help others as well. If you don't have a strict reason to keep it internal, make it public, put it on vipm.io and share it with the community. There is the possibility to use a private repository with VI Package Manager, though this will require a paid license. So there is a paid subscription for the VI Package Manager that you can buy, or a paid version. And if you want to use a private repo and keep it inside your company, publish your own packages there, you will have to buy the pro version of VIPM for hosting this and also for each client that wants to pull the package. So keep that in mind. That might be a costly alternative, but of course it's super handy if you're using vipm.io anyway. Might be the way to go inside your company. Yeah, still very easy, publicly. This one is wrong. It's internally accessible. You have version management, it's self-hosted, but of course you have costs and it's a third-party software. And GPM also has a global repository. It's again also open source, so when you're using it, you're actually encouraged to use their public repository for sharing your packages, but it also comes with a private, free private repository option that you can use through command line, so you can set up a private repository for it. And as I said, the whole tool is free, so also that option is free when you're using G-Package Manager. Yeah, but of course, downside, it's more complex to use that. You have to use a command line command, but yeah. And the last I want to be mentioning, publishing on GitHub, GitLab, Esto, whatever you're using internally. And it's just since we got that feedback from the last time we did this presentation on GDevCon, I want to be very clear about this. You should not be pushing your artifacts, so your VI packages, your zip files, whatever you're building, just into your repository on Git, but you should use the releases section for that. And the releases section is basically just like a free file storage where you can upload your files. And then you will have a VIP file to download as well as the source code that resulted in it. That happens automatically. And that's, I would say, a very viable way to distribute your packages internally if you're using a private repository and then invite your colleagues as collaborators, or you make it public that way. So I must say that's the way I always publish stuff if I have toolkits or something, this way on Git. And then maybe I upload them additionally into vipm.io. to have them also there easily accessible. Yeah, so benefits of Git, it's an open platform, it's very common to use it, very common to do it that way. Publicly accessible, you can have version management, you can have different versions of your release that are accessible. It's more complex, it's a bit more complex, and you don't have a central library for all your packages, it's inside your repository basically. One more benefit that I would put on here is you can automate GitHub, GitLab, and so on. You can automate it quite easily. So you could have a continuous integration pipeline where whenever you're pushing your toolkit code to your Git repository, it will automatically perform the build process and then automatically create a release for you with the new version. So that's quite handy. It's a bit of work to set up, but once it's in place, it's very easy to maintain your toolkit over time. Yes. Oh.
You had in your GitHub.
Yes.
And that was something you created using VIPM?
The VIP file is something I created using VIPM, yeah. Or
you can use VIPM to create the VIP file without putting it on VIPM.
Absolutely. You can create a VIP file just locally on your disk and then send it to a colleague via email, put it on your network drive, or put it on Git.
Publishing.
Exactly. Publishing and creating is separate. That's why I separated in the presentation also a bit. So creating a VI package file does not mean you have to share it. All right. So coming to final conclusion. So what to use? As I said, there's different use cases for all of these situations. And yeah, let's start with the first one, the one that I started with. I want to share my code with a colleague. I would say just go with the source distribution, maybe go with the PPL, so you have a single file, you can email it to your colleague or whatnot. Very easy to do, no big configuration files, build specifications, and so on. If you want to sell proprietary software, if you want to sell your toolkit like from your company as a paid tool, definitely use the LabVIEW installer and possibly with a PPL inside to keep your code protected, or with a source distribution if you don't mind having the code, the source code open. Also, as I mentioned, this may be upgraded in the future to be part of the NI package manager experience, but there's no roadmap on that at the moment. If I want to share my code with many colleagues, I would recommend going with VI Package Manager and publishing it on Git, so you publish it internally. You could, of course, use the VI Package Manager, and publish it in a private repository, but as I said, that's a paid option from JKI. So I think Git is very viable here too. If you want to share it with the community, definitely go with VI Package Manager and community publishing. That's the most common way of publishing your toolkits. And if you're working on very complex workflows, continuous integration, then I recommend using either gPackage Manager, which is the command line tool that's installing into your project directory, or you can work with VI Package Manager and JKI Dragon in these cases and have JKI Dragon always install the right versions that you need. All right, with that, I'm done with the presentation. Are there any questions? Yes.
I know it's not exactly a package manager, but I'm just curious, Git submodules, where would those fit in? What are your thoughts on that, and how could those be used to share reusable code?
Yeah, Git, I was actually thinking about getting them inside, but I was thinking if I put Git submodules inside, I would have to at least do a little introduction into Git as well. Maybe a short hand sign, who here is using Git? So. Okay, then so Git submodules is a way to have basically a repository inside a repository, so you can link another repository into your Git. And there's different scenarios where you would want to do that. So especially if you want to keep working on the submodule code and have everything in one repository, that's definitely a situation where you could be using Git submodules. So if you want to continue evolving that toolkit that you're working on. But if you have the toolkit as a separated piece of code, I recommend not using Git submodules because you really want an artifact. You want a final version that's not modifiable in that state. The issue with Git submodules very often is if you're using them heavily, you always have to update them at the beginning of your development cycle. Basically, you have to do a submodule update to get them to the latest version. If you forget that, you may be working with older versions for a long period and then get merge conflicts later on. So I heard actually a lot of headaches from customers using submodules heavily. But I myself never stumbled into that, so I found them very useful in cases where I really want to have the whole source code modifiable. I want to be able to change stuff, but I still want separate repositories because I don't want to push everything in one single big one, and I may want to reuse them for different projects also. Another nice way where Git submodules are helpful is when you want to have, let's say you have 5 different toolkits and you want to quickly check out different versions of them again. So you want to be able to use Toolkit 1 in version 1, Toolkit 2 in version 3, and so on, and change that on the go. So that's a thing for test systems, I would say. If you're building test systems for complex products, you may have your test steps in a submodule, and then for this specific product, I can check out the test steps that I needed. Whatever, I'm testing a computer, it has a RAM test, has a ROM test, has a disk test, and so on. And I can have all these tests in a separate submodule. And then when I'm opening or when I'm scanning the DUT, it will automatically check out the right submodules for me. That's a use case I see also for submodules. But on the other hand, that can of course also be achieved using build packages. So it always depends on how flexible you want to be with that. Yes.
Can you speak again about the line between the NI package manager packages and the VI package manager packages and when to use which?
Yeah, so as I said, the NI package manager, I put it in the presentation, but I do not recommend using it for toolkits at the moment. There's just no good reason, I would say. It's good for distributing your applications. That's what we are recommended for. But if it's toolkits, if it's LabVIEW VIs that you want to publish, definitely go with the VI package manager. It has all these features that we saw, palette building, renaming, relinking the examples, and so on. That's very handy. The NI package manager is really much simpler when it comes to that. It's really just putting files to a specific location on the target machine. And the benefit of one benefit of the NI package manager is it can already link to other NI packages, so install DACMX and LabVIEW and whatnot. But you can also do that using the VI package manager and JKI Dragon that can then install those packages.
All right, I have a follow-up then. Do you know if you can install VI packages from an NI package?
No, that doesn't work. So VI package manager, packages can only be installed by the VI package manager. So you also don't see them in the NI package manager list, basically. Yeah. All right. Other questions? Cool. Then I thank a lot for your attention, and I think we're perfectly on time.